today we are going to talk about the question of chapter 1 from KMM set 23-24. So we are given that a mass spectrum that contains the isotopes, and then we have their masses, magnesium 24, 25, 26, and also with their abundance. So we need to calculate the relative atomic mass, but we should calculate the average atomic mass first. Please don't forget about this, because if for average atomic mass, right, it has a unit over here, but if for relative atomic mass, it does not have a unit over here. So to calculate average atomic mass, we need to times on the relative their abundance and also their masses over here. So we times on, and then there's a sum value, so we need to sum up all, and then afterwards we will divide into their total abundance over here, and then we will get this value. So afterwards, we will need to transfer this value we get into here, which is the mass of one atom of an element, and then we divide into 1/12 of the times on with the mass of one atom of 12 carbon 12. So it's carbon 12 over here. So you will get an answer of the same value, because 1/12 times on 12 is equal to 1 only. But we will eliminate out the value of AMU, since over here actually we have an AMU, yeah, because the mass of one atom of carbon 12 is have a unit of AMU. So over here we will cancel it out, and then we will get a no value, remember, no value over here. So and then comes on. And now we will need to calculate for the question B. So we are given the information that we have a hydrocarbon, and then CX and then HY, and then it burns in completely in the pure oxygen, which is O2, because oxygen gas should be in, you should write it in O2, and then it will produce CO2. Okay, it will produce CO2 and also H2O. Yes, we obtain it, so it produces these two things. And then so how we can know that? So because we need to know this, we need to have to know because including what's included inside this, which is C and also H. So we need to calculate the mass of C and mass of H first. So the mass of C will be calculated by, also we need to know the molar mass. So we can just simply use this formula to get its ratio. So because we need to get the C only, so we use the molar mass of C divided into the molar mass of carbon dioxide, and then so we will get a ratio over here. So when we times on the mass, we will get the mass for C only. So you just sub in the value 12/44 over here, and then times on the value 21.5 value will get from there, and then you will get the mass of carbon is 5.8636. Remember to keep it as 4dP first, because this is not the final answer yet. And then afterwards, you will need to calculate for the mass of hydrogen. So because the second element that we included is the hydrogen, so we need to calculate for the hydrogen. We're using the same concept to find the ratio first, and then times with the mass, and then we will get a mass of hydrogen over here. So the same thing is you just sub the value over here, and then you will get this final, which is remain 4dP. Don't forget about it. So now we are using the method that we learned from the our SPM previous. We also use this method. So we will list out the element first. So C and H, and then the masses is over here and here. You're going to fill in from here to here, and then you will need to calculate the mole. So you will need to calculate the mole by using the masses. Okay, sorry. So you just simply use the mass divided into their molar mass. So you will get their mole over here and over here. So to find the simplest ratio, we need to divide it into the smallest mole that we get over here. So the smallest will be this. So it will divide itself to get a 1, and then here we will use this to divide with the smallest value over here, which is this. Okay, and then coming from here, and then you will get a value of 2.017, which is approximately to 2. So you will get an empirical formula of CH2 over here, because 1C and then 2H, so CH2. And then the second requirement is if the molar mass of the compound is 126 gram, so gram per mole. So what is the molecular formula? So because this one is just the empirical formula, so we know that the molar mass is 126. So n times the molar mass of CH2 will be equal to 126 because we know that empirical formulas is always the simplest form. So the n and then the empirical formula will be the molecular formula. So this one is empirical only. Okay, so the molar mass over here for the CH2 is 12 times on plus on 2, so you will get a value of 14. So you will 126 divided into 14, you will get n is equal to 9. So molecular formula, you just simply sub inside, then n is 9, and then CH2. Okay, so you get a value of C9H18. So this is the value that you will get. So for the C part, we will need to calculate about also, okay, for the question, we are given a bottle of concentration nitric acid solution contain the 85% by mass and has a density of 0.8362 gram per ml. So we need to calculate about the molarity. So to calculate the molarity, we need, first of all, we need to list out the information that we get first, which is the percentage by mass is 85%, and then the density is 0.8362. These are the two information that we get. Okay, that we get the information that we get. So because the information that we get is percentage by mass, so we need to assume the mass of solution to proceed with our afterwards calculation. But why don't we use the because actually we can also assume the volume of solution, but why don't we use it? Because we are given by the percentage of mass by mass, so we just assume mass of solution will be easier. So over here, you should assume the mass of solution to be 100 grams, and then you will calculate, you will get your mass of solute because we have a percentage by mass over here. Okay, so afterwards we will need to calculate about the density. So over here, the density, right? Okay, so the density over here is 0.8362. We just get the value over here. Okay, so what is our mass of solution? Our mass of solution 100 gram, and then we divide into the volume of solution, and then we will get our density. So in this condition, we will get a final answer for the volume of solution because these two values we have already got, these two. Okay, so you'll get a volume of solution of 119.59 mil. And then the next step will be calculating the mole of solute HNO3, because we know that the mass of solute over here is 85 grams over here, and then we divide into the molar mass. The molar mass, we can just calculate it out because H is 1, N is 14, and then O is 16, but we have 3 lah. Okay, so over here we will get the mole of solute is 1.349, and then so we get all the information that we want to calculate for our molarity, because our molarity will need the mole of solute and also the volume of solution. So the volume of solution we already get, yeah. So over here, what is the mole of solute? Yeah, we already get it over here. So we can get our answer, but remember to change the volume of solution from mil to liter. Yeah, because so you'll get an answer of this. Yeah, that's it for part C. So for part D, it is stoichiometry in balancing equation. So it is in acidic condition. So first of all, you must need to determine which one is oxidation and which one is reduction, right? So you will need to calculate for its oxidation number. So this is the calculation for the Mn. Okay, so magnesium over here, no, it's manganese, sorry. Okay, so over here, Mn, we just make it as unknown, plus on 4 oxygen, and then it will equal to the negative sign because the charge is -1. So as we know, oxygen is -2, and then times on with 4, you will get a -8. But when you make it here, it will become positive plus on 8, and so you have +7. And then the part charge over the other side will be +2. So the oxidation number decreases, so it is a reduction. Same is over the carbon over here. So we calculate so we have 2 carbon over here, we just right, jot it down. And then for oxygen, and also the charges is -2. So over here we can calculate. After you calculate, you will get that the carbon is +3, and then the carbon over here is also the same equation, the same method, and then you will get that the final carbon over here is +4. So the oxidation number increases. What is mean by it is a oxidation process. So we'll get a oxidation equation and reduction equation over here. But when you write out it over here, don't forget to add on the aqueous state or gas state. It is important for you to score marks. You should write it and remember to write it. So we now proceed to balancing the equation. So the first step will be balancing the other elements beside O and H. So we will see the oxidation part first. Is there any element which is different? Yes, there is, because here we have 2 carbon, but yeah, that's here. We have 2 carbon, but over here we just have 1 carbon, so we need to write a 2O here to let it have 2 carbon, which is same as here. Both of them are same. And then the next step will be balancing oxygen, but the oxygen number over here is already the same for these 2 parts, because over here we have 2, okay, oxygen have 2, you have 2 oxygen over here times 2, you have 4 oxygen. Here also have 4 oxygen. And then is there any hydrogen? No hydrogen over here, so we don't need to do anything. So over here, but we have an imbalance in the electron, because here is -2, 2 negative, and then over here actually we don't have any electron, right, and we don't have any charge. So the charge over here is -2, but here is 0. So how we can make it the same? So we just simply plus a 2 electron over here, so they are balanced now. -2, -2. Okay, so so we will proceed to the reduction part first. Okay, so is there any imbalance in element? No, because Mn are besides OH lah. So okay, they are the same. Okay, so afterwards, what's the imbalance? Yeah, so for oxygen is imbalance. Here we have 4 oxygen, but over here we just okay, here got 4 oxygen, but here we don't have any oxygen, so we need to add on water. So we need to add how many? We need to add 4 water over here to get 4 oxygen. So when you add an oxygen over here, you will have an imbalance of hydrogen, because here got hydrogen but here don't have. So how many oxygen that we have over this part? So we have 8 hydrogen, right? So 8 hydrogen, so we need to add 8 hydrogen ion over here to make it the both part of hydrogen is the same. So balance the electron. So over here we have negative, okay, and then 8 plus. So now it is, okay, so now it is 7 plus, and then over here we have 2 plus. Yeah, so 2 plus. How we can make it same? So we can just do it over here. So we need to plus on 5 electron, which is this, to get them the same charge of for the both side. So okay, so we will get an equation of this and this equation. We get these 2 equations. So but then when we want to combine it, their electrons should be the same. So over here 2 electron, over here 5 electron. So we need to times on 5, and here need to times on 2 for the whole equation, so that it will be the same. So after we add that, you will get equation of this, the final equation of this, and then you can just combine it, and you will get an answer of this. Yeah. Okay, so for the part E, right, so we have get the information of manganese dioxide reacts with hydrochloric acid to produce magnesium chloride and then water and also chlorine gases. So it gives us this equation, which is our information, one of our important information. So we have 0.86 mole of manganese dioxide react with 48.2 gram of hydrochloric acid. So first of all, you will need to list out the information you get over here first. So and then you will need to calculate the mole to calculate which one is the limiting reactant. So over here we have already get the mole of manganese dioxide. So we will need to calculate for the mole of HCl because the information that we get is the mass. So how to calculate the mole? We need to use the mass of hydrochloric acid divide into the molar mass. So and then you will get the that your mole of hydrochloric acid is 1.32 mole. So by using the concept of here, 1 mole of manganese dioxide will produce 4 mole of will react, sorry, it is react, you must don't forget this sign. It will react with 4 mole of hydrochloric acid. So yeah, so we have how many? MnO2 we have 0.86, so we times 0.86 here, and then we times 0.86 here also. So the moles of hydrochloric acid that we needed is this, is 3.44. And then how about how many moles that HCl that we have? That we have is 1.32. That we need is, well, our need is 3.44. So the HCl number of mole of HCl needed is more than the number of HCl we have. So this HCl is a limiting reagent. So don't forget to write this sentence out. Okay. Okay, so for the final part, which is the mass of chlorine gas produced, using the same concept, we coming from the equation here, 4 mole of hydrochloric acid will produce 1 mole of chlorine gases. So we just write it out over here, and then you will divide it into 4 first to for you to more simpler to get a 1 easier for you to calculate. So divide into 4 over here the same, so 104. 1 mole of HCl will produce 104 mole of chlorine gases. So we have 1.32 mole of hydrochloric acid. So we'll use like same over here, and then we'll times, because when you times, you must time at two places. So we will produce 0.33 mole of chlorine gases. So to calculate the mass is the same concept. Yeah, so you need to use the mole to multiply with your molar mass to get a final answer of 23.43 gram. Yeah, so that's it for this question.